Alright, so down here in our main, we've got this eat spaces. So now we've taken our string here and reduced it down to just be 2 plus 3 times 4 minus 7. And then we moved on to the next piece and said, okay, after I eat those spaces, what should I be able to do? Well, I should be able to evaluate this expression. So now when I call expression here with that character string, we're then going to go ahead and grab the first term, set that equal to the value, and then start looking through our list, and we're looking for either a plus, a minus, or a /n, which is always found at the end of a string. Once I hit the /0, I know that I've hit the end, so I'm good. So let's go ahead and call that and see what it does. So now down here, after we verify that we can eat the spaces, now we'll call it expr, and we'll pass it in buffer. Of course, I like to see the results of that. If I don't save that on the left-hand side, I won't get it back. So I want to go ahead and print that out. So I'll go ahead and print that out to the screen. Answer is buffer. And of course, if you don't like using all the std colons, you can put that using namespace at the top, get rid of that. That way I don't think type those anymore. So now if I run it just like that, we can see where we're at this point. I believe we got stopped last time right in the middle of creating the number function. But we'll try it again. 2 plus 3 times 4 minus 7. And I got the answer is 2 plus 3 times 4 underscore 7. All right. So now let's go look through the code and see what we're doing. So go ahead.
Sorry, let me get that right.
Sure can.
I was in the wrong file.
No problem. So now what we're going to do is we're going to scroll up and see what we're doing with expr. Matter of fact, here I forgot to write expr on there, so that's why I printed out buffer again. Let me call expr so we can see what we're currently doing, if we're doing anything yet. And I'm going to try that one more time. 2 plus 3 times 4 minus 7. And I got error occurred. Alright, so we're getting somewhere in there.
Thank you.
Let's go see where we left off. So we got up here to expression. We're trying to evaluate this expression we have. We start off with the value being 0. We go ahead and call term to get the first term off of our string. So let's go check out term. I scroll up and look to see what we did in term. There it is there. I take that character string followed by what index I'm currently on. I then grab the value. I say that value equals a number. I need to pull a number out of the string. That's the first thing that we should find. So let me go check out and see what number does. In this case, number, that's where we stopped. We accept that character string and what index we're on. I set my value to 0, and then I check to see, hey, is the first thing I'm looking at, is that a number or not? I'm using this is digit. So I'm taking this character that's in here and saying, is this guy a number or not? If it's not, I'm printing out this cout statement and calling an exit. So now I've got what happens if something goes wrong. Now I need, what do I do if something goes right? So what should I do? Well, I'm sitting at this index here. What should I do with that character that's there?
Save it.
Save it, right? Where do you want us to save it at? Oops.
Right.
So how about value? Because that's what we're going to store there. Now how do I convert that character to an actual digit?
Static cast.
Static cast? We can try that. Huh? String int. We could try it that way. Let me do it the longer way, and let's just take the value that's in there, which would be str index, and subtract off a 0. So that would take whatever number is in there, subtract off that 0 as a character, and that would give me how far off it is from 0. So I should be able to get the number back.
Why would you put the number as a character?
Because it's a character inside of here. This isn't the number 2. This is the ASCII character 2. Well, in the ASCII table, it goes from 0, 1, 2, all the way up to 9. So if I take what the value of 0 is, the distance between 0 and 2 should be that number. So there's a little trick we can use to convert a number that's a character to a number that's a actual integer. So we can try that, see how it goes. So again there, if I hit save, let's see what that would do for us. Now hopefully the number will return back a good one. Build it, see where we're at. Enter your expression, 2 plus 3 times 4 minus 7. And I still get an error occurred. So now I need to go figure out where we are in our error. So if I wanted to walk through this code step by step, what would I do?
Look for something that actually prints out error occurred.
Okay. So what I'm going to do it a little bit less than that. I'm going to put a break statement in and say, hey, I want to stop right here in this code, and from right here, I want to walk through this guy and just see what it's doing. So from here, now I'm going to go hit bug and hit start debugging. It pops up, so 2 plus 3 times 4 minus 7. And now I'm sitting right there. So now, with these little buttons up here, I'm going to start stepping through this code so I can see what it's doing. Should I pull this down or not?
Yeah, probably should.
Does it help? Alright, so I'm right there. I'm going to hit this step into button because I want to step into that function. I step into it, and now I'm at expression, EXPR. I'm going to hit the step over button. I'm on line 51, 52, 53. There's a function call. I'm going to step in. So I click that step into button. Now I'm at the term function. I can step over, step over. Oh, there's another one. Step into, step over, step over. Now the question is this guy string is currently 2 plus 3 times 4 minus 7. If I move my cursor over the index, index is 0. So the question is that guy a digit? I hit step over. It was a digit. Now value equals str index minus 0. And then my next line, step over, I get to the end. Well, what did I not do in this function?
Return.
We didn't have a return. We said right here that we're supposed to return a double. I didn't. So let's go ahead and fix that while we're there. So here we'll say return value. Because again, once I pull that guy out, I need to make sure I know where we're at. And I'll hit the next key, or step over. And now it says, hey, you've changed this guy. You know what? Probably be good right now to go ahead and stop. Build it again. Start over. Now that it's built, again, start debugging. I didn't move my breakpoint, so it's still sitting in there waiting for me. 2 plus 3 times 4 minus 7. Right there again at line 79. Step into, which is that guy. Step over, step over, step over. Step into. Step over, step over. I'm going to hit step over real quick. And now if I roll my cursor over value, I now have a 2 in there. So number got called, and it's got 2. Perfect. Seems good. I'm going to hit step over. And I'm currently got index being 0. And string is still 2 plus 3 times 4 minus 7. Now, I'm going to say if string at index 0. Well, what is string at index 0? Well, it's a 2. Well, up here when I grabbed my number, what didn't I do? I didn't advance it, right? So there's where our current fallacy is. So let me go back up here to this function. And now that we've found a value we like, I'll do index plus plus. Put it on the next line. So now I can increment that index. And again, because we pass it in by value, it'll get sent back. So it'll get updated in that function. Because we're passing by value, not by, passing by reference, not by value. So because it's by reference, you don't get a copy, you get the actual value. It gets changed, and when it goes back, it's now updated. So now that we made a code change, I'll hit the stop key. I want to go ahead and build it again. And we'll run it one more time. So 2 plus 3 times 4 minus 7. It stopped and waited for me. So now we'll walk through here. Step into, step over, step over, step over, step over. So now index is 1. Now we're checking here. Was it a star? Nope. Is it a forward slash? Nope. Step over. Then I get a break. Returns value. So now in this case, my value is a 2. I now have a 2. And then here, I then look at the next step. So I'm going to hit this step over. And now I'm looking at which guy is it? It's a plus sign. Awesome. So what happens when it's a plus sign? I'm going to call term again. And then go see what I currently have at that index. So I can hit the step into button. Now I'm back at term. I can see that index is now 2. So if I put my little cursor up here, I lost my marker. So now I'm sitting right here because that's what the second index is. So of course, what do I expect to find? I expect that that should return a 3. I highlight my cursor. It's got a 3. Perfect. I go over. Now I'm checking to see if the next guy is an asterisk. It is. So now what do I do? I multiply that by the next thing that we find, which should be a number. So value is currently 3. I hit the step over key, and it went away. I must hit the stop key. So let's go again. 2 plus 3 times 4 minus 7. Step into, over, 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 over. Step over, and it's done. So let's go see what our result was. 2 plus 3 times 4 minus 7. And I still got an error. So now we need to go see why we're getting this error. We know we got all the way to the multiplication sign. So now we need to actually step into and go see why that guy isn't giving us what we like. So start debugging. 2 plus 3 times 4 minus 7. Step into, step over, step over, step over, step over, step into, step over, step over, step over, step over. And it looks like we currently have a value of 3. My index is at 3. Step over. It's an asterisk. Step into. Step over, step over. And that's where it says, wait a minute here. Index is a 3. And then I get this error printed out. happening there?
It caught the asterisk.
Once we found the asterisk, what should we do? We got to skip over, right? Once we find it, go to the next one.
We didn't increment our index.
So we didn't increment that index. So down here, when I find this asterisk, I want to increment that guy. Go to the next one. So let's try it one more time.
Wait.
Yep.
We'll have the same problem with division if we don't go take care of that
We
one.
sure will. So now that we're here, we found one problem. Let's fix it on this line too, because we make sure we increment that guy each time. Now notice I put the double plus sign in front of the variable, not the back. The double plus in front says it's a pre-increment operator, which means increment this value first and then use it. So I want to increment it first and then pass it to the function. So that's why I put that on the left side of that variable. So now let's try it again. Hopefully we're getting closer. So build solution, it built. So 2 plus 3 times 4 minus 7. I got the answer of 7. Well, we're getting closer. So how do I know what happened in there? Debugger, right? Let's walk through it and see what it's doing, because we thought we had it good. Let's walk through it and see if we missed any other increments. So again, start debugging. 2 plus 3 times 4 minus 7. And now we're sitting there. We step into that guy. Step over, step over, step over, step over, step over, step over. At the end of this guy, I now have the value of 14. All right. Step over, step over. I now find the minus. My value is 14. My term is, let's go see what it is. Step into, step over, step over, step over. And of course, I end up with a 7. Step over. I'm going to go ahead and hit continue. And it looks like we might have a good solution. 2 times 3, or 2 plus 3 times 4 minus 7. I get 7. Is that right?
Yeah.
It's actually right? That's what really we expected. So let's throw something else at it. Well, what else would you like to try?
What happens if we give it a 2-digit number?
Great question. So let's take 22 plus 33. Choose the plus sign. I get 22 plus 33. Do you want to debug it or just execute? Live on the edge. Hit execute. Alright, so start without debugging so I can see the output. 22 plus 33. I get an error occurred. What happened? Didn't account for multiple digits. We're just grabbing one, moving on, right? So, where do we fix that at? So up here in number, I'm just grabbing one guy off of there, saving that into value, and then we're returning it. What should we be doing?
Check to see if there's another number.
Is there one following it? If there's 2 in a row, that's another case, right? So, what should I do here? Some kind of loop, right? Well, how long do we want to go?
Until it runs out of numbers.
Till it runs out of numbers. How do I know if I'm on a number or not?
Is digit.
Man, you guys are awesome. So is digit, str, index. So while it's a digit, now is digit returns true or false. If I wanted clarity, I could put this in there if I'd like. Most programmers don't, because of course it always equates to true. So I'll go ahead and leave it out, that way I can be as lazy as everybody else. So while it's a digit, what do I want to do while it's a digit? Take the value equal to that, and then increment my index. Is that going to work? No. Why not?
Because you're gonna override it every time.
Alright, so I'm just going to grab the next number and put it in the value. What do I need to do?
When you put it in the while loop up at the top, you know, like after the double. No. So I guess you gotta read it first.
I got to make sure I have a digit. If I don't have a digit, don't do anything else. But if I do have a digit, and we get down to line 30, so yes, I have a digit. What should I do with it?
Would you add it like in a string, like you would add a string together? And you put the numbers side by side? Not sure how you do that, but.
So, I keep losing my marker. So, let's just think about this here. I've got the number 22. First time I come in here, I go, oh, there's a 2. What do I do with it?
Set it somewhere.
And then what will I do?
Look at
Oh,
the
here's a
next
2. What do I do with that one?
Put it beside it.
Beside it.
How do you put it beside it?
Multiply it by 10 and then add that number onto it.
There you go. So 22 is really 20 plus 2, right? So what does multiply this guy by 10 and then add it on there? What if I had 223?
Multiply it again by 10.
Then I just multiply all of this by 10 and then add in the 3, right? So looks like I got a pattern there. If I just say value equals value times 10 plus the result of this guy, that work?
Should.
Can't you just go?
Should, right?
Yeah.
Say again?
Can't you just say times equals 10 times? Or is that a different language I'm thinking of?
You can. However, sometimes people get lost on which one has order of precedence on that. So if I have multiple operators in one line, I won't do it that way just for clarity. But yeah, if you did a times equals 10 plus, what would that do?
Should be.
Multiplication
Take
is
it, so
precedence.
multiply it by 10, and then do that.
You would assume so. That is not always the case.
Does actually do 10 plus.
Right. It does the operation on the right first, and then takes that by this time equals. And you'll see why that happens when we get the operator overloading, because this is really just passed to a function, so it equates this first, and then passes it in. So this gives you a different answer. So because we're doing multiple here, we'll do value plus 10. So, that fix it?
Yeah.
Possibly.
Possibly, right? How do we know for sure?
You're right.
Run it, right? Give it a shot. 22 plus 33 equals 55.
Nailed it.
Nailed it? Well, let me try a few more, because 2 divided by 3 is 0.66667.
Close enough.
Close enough, yeah. Alright, so,
I know what.
Huh.
Decimal.
what?
Dude, 22.5 is not gonna work.
Why not?
Because you're not reading, don't have anything to read the decimal yet, have you?
Error occurred. So how do we read a decimal? Well, we figured that one out. Why can't we figure it out?
'Cause we don't
I think
know-
we can do it.
I say because we don't know how
I got
decimals
things
are
in
stored in memory.
Uh,
The floating point numbers are stored in memory.
doesn't matter. So,
Sure.
if I use the same concept here, now I've got 22.3. So I read the 2. We know what to do with that. I read the next one. I know what to do with that. What do I need to do when I hit a decimal point?
Divide the new number you get by 10 and add it on.
I was gonna say.
So,
Divide 3 by 10.
But that won't work.
oh, okay.
Because if you put another 3 after that, 22.33, you'd have to divide the new one by 100. You can't just divide it by 10.
Keep doing by 10 the same way, right?
No, because then that would give you 22.6 stored. You take the new number divided by 10.
You're right.
So you're going to have to go almost to by 10 to a power. I don't know how you determine what triggers you starting the power.
Okay. So what what should we do? We're on the right track.
Well, if we
Pretty
do that, the power would just increase by power of 1 each time. So first time it's 10 to the power of 1. Second time through the loop. So if we just do a loop with a counter,
When do we initialize the counter and when do we reset it to?
it initializes at the start of that loop.
I would just concatenate the string and then cast it.
This is why you just touch and play on the computer.
What are we gonna do here? What's your idea?
I also like the concatenate. That's the easier way.
No. So
It's easier than having to do a loop.
But
it is probably easier having to do a loop, yeah.
here's the thing.
But now you're
Right before
learning.
we do the while loop, we would just need to create a variable that would actually keep the count.
Yeah, and then you just raise it to the count
Yeah.
each time.
Well, how about
Trigger that off of hitting.
when the program is first executed, have a statement that says calculators are cheap?
That'd be a way. All right. So how do you want to deal with this decimal besides concatenating it?
Actually,
Make it easy.
anyways, whenever we hit the decimal, it's going to kick us out of our loop anyway because it's no longer going to make its digit true.
That's true.
So we would have to almost say, while is digit or equal to dot.
Or dot?
If we encountered a dot, then proceed forward using the loop for a decimal.
I had a really stupid idea just now. If dot and then have the while loop going again. I have a second copy of it. Okay, and I look up and that's going to get function.
So once I find a dot, then what do I do?
Same loop, but instead of value times 10, it's going to be divided by
Or times 0.10 or whatever.
We're gonna have to create a counter
Yeah,
variable
we're
first
going to have a different counter.
Okay.
and initialize it to value 0.
Okay. Then what?
I think we're going to go with 1.
Okay.
We're going to go 10 to the power of, we're dividing by 10 to the power of factor.
Yeah.
So I found these digits. All of a sudden I didn't find a digit. Then what do I do?
You're going to, if the string index is a dot, the first thing you're going to do, wait, what? Why did you get rid of, why did you make it not equal?
Well, because if I didn't find a digit and I didn't find a decimal,
Okay.
I'm done finding a number. Return the number. But if I didn't find a digit, but I did find a decimal, what do I want to do?
Well, then you're going to have
Okay, this is
string
where we'll,
index is equal to dot.
The what?
Well, no, because you don't need it because you've already used that if statement. So now we can just go,
now we can just go ahead and start with the loop because it'll break out of this once we
we
return.
need to do index plus plus because we need to kick over the dot.
Okay.
And now's where we need to define our counter.
While
Variable.
digit.
Factor? Or-
Yeah, because there's no point in declaring it until after we've known that we need it.
I'm in.
Okay, what about, instead of dividing by 10, multiply by 0.1, and then also each time it's looped, like we're talking about moving each decimal place, each time it's looped, multiplying it by an extra 0.1.
Sounds great to me.
That's what we're doing except different because we were dividing by 10 to give us 0.1 and we were going to divide by 100 to give us 0.01.
And then, for each increasing decimal spot.
Because I can't
So we're
think of
still
a way to
saving
put another
math-wise.
0 between the 0 or between the point and the 1. And Randy's not helping us. He's just laughing.
I'm not a math major. I told you how I would have done it.
All right. So
Y'all have done nothing.
So now that we have another digit, so now we've found the 3. What would I like to do?
Well, the value's been
Value plus equals.
Just to be more clear.
Okay.
equals value plus. Then we're gonna need the string index.
Minus character 0. We'll name it that parentheses.
All of that raised to factor.
All of this divided by 10 to the power of
Factor.
factor. Yeah.
All right, that's good.
And it's not all of it, just that one
Yeah.
quantity.
Well, yeah, just the parentheses on the right. No.
That does it. But we want that.
That's lazy. That's nowhere near.
No, that's great.
Convoluted and complicated.
But we'll want to move that. Oh, okay. Or that works too. Yeah, I like this.
That work?
That is less convoluted. That is far less convoluted than
Yeah.
what's going on in my head.
A little bit.
Okay, so when you're declaring,
It's exactly what you were saying.
Yeah, because he was looking at a way he showed us how to keep the value of factor, which I was not thinking of.
okay, what is factor again?
Factor is 1. And then the first time I find a number past the decimal point, factor is 0.1.
Oh, okay,
And
okay.
the next time I
Factor
find a
storing-
decimal, it's 0.01.
Factor is storing the decimal.
Factor is storing how many decimal places you are into it.
Where'd you do that?
This times equals.
Because he's going 0.1 times 0.1, so he's taking a tenth of a 10, then he's taking a tenth of a 100, then a tenth of 1,000, then a tenth of a 10,000.
Yep. That makes it a little more clear.
Requires a few less numbers than what we were thinking.
Yeah. That work for you?
Well, I'm just not seeing where factor is actually storing the amount. Factor's not storing it, it's storing the index.
Nope. So factor is how many spaces am I past the decimal point.
Oh.
So once I read this 3, what do I want to do with it? I multiply it by 0.1 to get 0.3, and then I add it to 22. And then when I get to this one, how many? I'm now no longer in the tenths. I'm on the hundredths place. So now I got to multiply 3 times 0.01, which gives me 0.03. And I add that to 22.3. That gives me 22.33. And then if I had another number, my factor would be 0.001. And that'd be 22.33 plus 0.004, which would give me 22.334.
Do we need to take the value equals outside of the loop? Won't that keep making factor, like, wouldn't it keep making the value smaller and smaller because we're multiplying it by factor every time?
We're adding it on to the original value, so.
It's making this part smaller, just what you're reading, and then it adds it to whatever I had.
The plus sign is actually protecting the value from factor.
Correct. Because of the way the math has to work. Order precedence.
So that's still in the loop
Yep.
right there, where each time
You're just gonna keep doing it.
factor's getting smaller and smaller.
Yep.
We can always put parentheses around it just to make the order clear.
Most certainly can. I always like to comment for clarity.
Parentheses are free.
They are. Well, kind of.
There's
They do take up space, but
4 bits, right?
that's right. There you go. All right, so let's see if it works. I mean, worst happens, it don't work. We got to come try again, right? Yay! So here, let's do 22 plus 33. That still works. Of course, I got to run it again. Plus 33.44. Cross our fingers.
No.
No.
I'm sitting here with it just running,
Yeah.
and
our problem. What changed between what we did before and what we're doing now?
Wait a minute.
We never increased index,
That's right.
so we're looping on the same number.
There you go. So, save that, try it again. $55.77. Sound pretty close? Sure, why not? All right. Any other questions there? Do you want to make the calculator to do anything else? He said no.
They're making calculated derivative?
We could.
We'd have to have people capable of calculating a derivative to tell you.
Well, that'd be one of my questions here is how to design that.
This is
But yeah, we can do this. It's really easy with matrices. So the other thing that I think the book talked about was, what if I had a parenthesis? So if we were going to add a parenthesis, how would we do that? Where would we put it in this code that we have? So let's say I went to run this and I put 2 plus 3 times parentheses 4 plus 5.
You would simplify that to 9 and multiply.
Yes, that would be great.
You put it in your switch statement in the expression.
Yeah, I'd have to put it somewhere in the expression. So in here in this expression, which is down here, I have to do a check first and say, hey, if you're a parenthesis, I got to do just something special. I need to go evaluate what's in the parentheses first, and then keep going. So that's how I would do that. Do a parentheses. Questions there? Awesome. So what we have so far here is I have these awful looking cout statements with an exit command here. Well, instead of just crashing the program and tell it to exit, what would be a better way to handle this problem? That was covered in the first part of chapter 6.
An exception.
An exception, right? Which means something exceptional happened. I can't give you a solution, so I can't give you a good return value. So the book kind of cheated and gave you an exit 0 when it just talked about exceptions 2 pages prior and should have threw them in there. So, in this case, so instead of doing a cout and an exit, let's do a try catch. So in this case, when an error happens, what should I do? I should probably throw an exception, right? Say, hey, something happened here, had a problem. So now instead of doing a cout and an ENDL and an exit, I'm going to delete those out of there. Well, I'll comment them out, that way you still have them. And now, let's say we want to throw an exception. So now let's do a THROW. Throw an exception, and in this case, let's be a little bit more descriptive, because of course my exception is only as good as it tells me. And I'm going to put that inside of here, we have,
Unexpected character.
there you go, expected character. In this case, I'll put EXPR. And what happens when I do a throw?
You have to catch it.
Cause a lot of overhead.
I do. It stops executing right there and starts winding up the stack to see if somebody is inside of a try that can catch it. So since I threw an exception in here, I need somebody somewhere to catch it. So who should I have to catch this guy?
Whoever's running expression.
So I come down here to main. Oh, look who's running expression. Main is. So I do a try here. So now that I've surrounded that guy in a try block, now if nothing bad happens, this guy just keeps running, no harm, no foul. However, if an exception does get thrown, I need to catch it. So I'm going to write a catch. Now a catch, again, gives me those different options. I can either say I know what I want to catch, or I can get more generic and more generic. And the most generic is just doing a ... that ellipses. But in this case, I kind of know what we're throwing. If I scroll back up here and look, what did I just throw out of here? Character string, right? So let's see if we can catch ourselves a character string. So once I catch it, what should I do? At least tell somebody, right? Now in this case, I'm going to try and operate this guy, and if something bad happens, I'm going to try and catch that guy, and then print out that message. So, what do I have to do to get that exception?
Parentheses.
Huh?
Parentheses.
Parentheses? Let's see if that'll work. Start with that debugging. It compiles it for me. 2 plus 3, 4, something like that. And there I got unexpected character in EXPR, open close parentheses. And that allows me to gracefully exit. Well, now in this case, let's say that I wanted this program to just keep going until you quit. Well, now, before the way we had it, it would exit immediately and be done. Well, now we can actually catch that, deal with the error, keep the system in a steady state, and then keep executing. So just like we did the throw here, I'm going to copy this and move it up and paste it up here when I exit it as well. So I'll comment those guys out. Now in this case, unexpected character in EXPR, I can put unexpected character in number. So now I'm being a little more descriptive about where my problem is. So what that's done is that's moved all of my messages that go out to the user down to one spot. So if any kind of error happens, it all comes back to one spot so you can deal with it and then move on. So instead of having a bunch of cout statements through my code, I've now just gone back down here to my main program that's running everything, and this is where it catches my problems. So now in here, if it catches a problem with the expression or a problem with the number, this guy catches it, I stay in a steady state, and I can move on and do something else. So there's how try and catches can help you. Now they do add some overhead. So I only want to use a try catch when it's exceptional. When I can't recover, there's nothing else I can do, but I don't want the system to crash. It's really important when I have other resources open that need to be freed up. So if I'm connected to a database, I'm connected to a lot of image files that are open, and my system crashes, I don't want those resources to be thrown away and open for an attacker or a hacker. I want to say, okay, something happened, let me clean everything up, I'll do all my closes, all my connections, free my memory, and then we'll gracefully exit and go, try again a little later. That's where exceptions come in.
So like a final compiled program could still have try catches in there?
They could,
Yeah.
but you just got to make sure you balance that with, are they exceptional, or are they just being lazy with my design? So you want to have as few try catches as possible, but there are spots that have them. So again, they do add overhead every time you add those try catch blocks in there. It has to add that trail path up the stack during that compilation, so it does add some overhead. Questions there? All right, so the next thing is let's do the exact same thing, but do it inside of CLR. Because CLR does some interesting things, so let's give that a shot. So I'm going to leave this program just the way it is, and then I'll right-click, and we'll do a add new project. And my fast computer will go. And then we'll do a CLR console application. And we can call this one calculator CLR. How's that? Ingenious. And then I'll wait the 20 minutes for it to make it. Now in this case, again, it comes up with all this extra stuff. It's got my header, my resources, a couple icon files in case you need them. some assembly information, but here's my main program right here, this calculator CLR. So if I go to that guy, it's probably already open. Yep, there it is. As you can see already, we're now using system : string for things, and it uses the little carets. What do those carets mean? Anybody remember? It means the memory's managed by CLR. So that caret means, hey, that's going to take care of the garbage collection. I don't got to deal with any kind of pointers. That's an array of data, and CLR is going to suck all that up for me, which is great. So I'm going to come back, and I'm just going to do a copy from this main, and we're going to change this stuff over to use CLR.
He's doing the whole main.
Yep, the whole main. So, what's different, and can't even see that. So what's different about CLR than regular ISO C++? Well, we had to get away from unmanaged code and get into managed code. And that's why automatically stdc out is getting underlined. It doesn't see it because CLR doesn't use it. So how do I print things in CLR? Console.WriteLine. There you go. Console, : WriteLine. And then now, I'll just hold down the delete key. Welcome to the calculator. And then we'll do another one. And I'll hold down the delete key. Alright, so now we're up there using the consoles. And then I've got this constant integer max 80 and this buffer here. Well, what does that look like in CLR? What's the difference between CLR and ISO C++? Well, again, these are system architecture dependent, and we don't want to use those because we want to use what's built into the system. So I need to use system : int32, system : character, whatever. But in this case, I really just want a string. Well, a string is just like this inside of CLR. So instead of using these two lines, I'm going to replace those with a string. So my string will look something like system string. And then I'll use the extra caret there to say, you manage it for me, because I really don't want to mess with it. So now I just created a buffer of string. It's as long as we need it to be, because CLR will take care of making it long enough. So now I can delete lines 12 and 13. And then the next line there is a cn.get line. Well, how do I do that in CLR?
Read line.
Just do a read line, same kind of thing. Console : read line. If I forget what goes in the parentheses, it actually tells me there. In this case, read line takes no parameters, but returns a string with a caret. Well, perfect. I've got one for you. So now in this case, at the beginning, we're going to say buffer equals. So now we're able to take what read line grabs, returns it as a string, and then I save that inside a buffer. So now what do we want to do? Well, I can get rid of lines 13. I'm going to go ahead and get rid of line 14. So the next thing I'm going to do is I am going to make sure that you didn't give me a blank line. Well, I can do that really easy in CLR because it's got a built-in function. So I can do, I think it's string : is null or empty. So if you gave me nothing, and I got to give it the string. So if you actually gave me nothing, I'm just going to return 0. So that's one way we're going to check and go, make sure you didn't just hit the enter key, because that's legal. So if you didn't do that, I can go ahead and print it out, and we'll call expr buffer. So I'm going to delete these out. And I will do a console.writeLine. Expression is, and then we'll do a curly brace 0, which means this is a placeholder for what's coming next. And I'll write a comma, and I'll do expr of buffer. So I'm going to remove this try catch for now. We'll come back to that in a little while. So now I've rewritten the main function to look like this. Whether you like this better or worse, not quite sure which is better. So this is what we look like in CLR. However, now I now need to go up to this expr function, because now instead of passing it a character pointer, now I'm passing it a system string. So let's go back up there to expr. If I go back to calculator, I'm going to copy it over. There's my expr. Copy. Paste. And there's expr. Now, what do we need to change to make this CLR and not be ISO C++? Well, the first one here is, of course, this character star. We don't use those here, so we use system string. And I use the caret to say, here's what's coming. So there's my system stir. So in here, I'm going to use, instead of using a integer, I need to use a CLR related item. What would that be? System, whoops. System : int. I can either take int 16, int 32, or int 64. I've got to be specific now. I got to make sure it's compatible across all the systems. So most people just pick 32 because that's the most common. And now they've got an integer there, and there's our current index. So once I got that guy, I then need to have a double value there. But again, do I want to use the double? Nope. What do I want to use? Type in system. See what your options are. I bet you if you type in a DOU, you'll get a double. Yeah. All of their structures start with a capital letter. So now I've got a double value, and now I've got an integer index. All right, we're getting a little more CLR compliant. Well, I see this double here. What should it be? System double, right? Well, I'm going to be even lazier and do a copy and a paste. So now we're doing system double there. Let's see here. So now I'm going to write this guy to say, while index is less than str length. Because now I know exactly how long it is, because the string now keeps part of it how long that guy is. So now I don't have to have this for loop that just runs forever, because now I know that I'm going to stop when I get to the end. Guaranteed. So then, once I'm inside of here, what do I want to do? Well, again, we'll do a switch statement just like we did it before. And now I type in switch, and auto fills it for me. Well, what am I going to do a check on? Well, I want to check right there where we were. Check right there on index. So again, what is it that we're looking for? Looking for pretty much just exactly what we had before. So I'm going to delete those out and move them up. So what do I want to do if I've hit the very end? We got a result, we're done, right? What do I do if I hit a plus sign? Same thing, right? Minus sign. Same thing, right? And then I've still got this throw on there, which we can deal with here in a little bit. So any questions there? So that's as easy as it looks by going from CLR over to ISO C++. I just got to get in the CLR mindset of, well, what all do I need to do to make it CLR, to make it managed? So I got to get rid of my integers and my doubles and my floats and make those guys system int32, system double. Instead of having character pointers, now I have strings. Now I have strings here. And that way it's managed for me. I don't have to deal with all those things going on down the bottom. I use this extra caret, which says, hey, you're going to manage the memory for me. So when I need more memory, it takes care of it. When I don't need more memory, it gives it up for me. I don't have to deal with news and deletes and pointers and those things. It's all done for me. So, any questions there? So I do the same process for each of those other functions. And then I would end up with a CLR calculator that'll work just as good, or if not better, than the ISO C++ one.
Now you said that the CLR is the one that you can use across the board, right? For different.
The Common Language Runtime is designed to run across different architectures. And that's why you have to use these definitions instead of the double and the int that are built into C++. Because those are machine dependent.
This is designed exclusively to work on Microsoft. It doesn't work on Linux and Mac.
Correct. So, but if I've got a 32-bit machine and a 64-bit machine, I'm guaranteed that the CLR will run the same on both, whereas the 64-bit machine would have extra sizes for their integers, where the 32 machine wouldn't if I used ISO-C. So because we're letting this Windows manage it, that's why it's called managed code, it does some of those things for us. But this guarantees that when this thing runs on one system, if I can get it to compile somewhere else, it'll run the exact same way there, which is a good benefit.
So most of the time you'll have less code because you're not worried about memory management.
You'll have less code, yes.
Yeah.
There'll be more code going on in the background that you don't see.
Yeah.
You'll think, man, I only wrote like 5 lines of code, but why is my executable, did this large? It's doing all that for you. If you talk about, just running on a desktop machine, this is great. We talk about doing things on like an embedded chip or on a phone, where we have, limited memory and stuff. Then some of the stuff isn't so helpful, because now it's adding your bloat to your size. So again, so wherever you want to place it at, most of the stuff with Visual C++ is all desktop based, doing applications for businesses and stuff. So it makes sense here. Any other questions? So hopefully that's what you were supposed to get when you read Chapter 6. Hopefully you got all that out of there. We start classes on Tuesday, and that's not just like school classes, but classes in inheritance and object-oriented programming, which can be a thing for some people. So I've got all week next week to work on doing some objects. So we got 15 minutes left, so if nobody has any questions, I'm going to jump into structures. No questions? Awesome. So I'm going to go ahead and save this, and I will upload this whenever it's done. And I'm going to open up one more new project. And this is just going to be a Win32 console project. And I'm going to call this Structures. Next, empty project. Don't give me any of the other stuff. Just give me a project. Right click here. I think I can make this guy the default. Somewhere in here. Set as project startup. Perfect. So close these down so they don't get in our way. I'm going to right click, add a new item. It's going to be a CPP file. And we'll call this structure main file. How's that? Alright, I got somewhere where to start. So I'm going to go ahead and do an int main just to kick things off. Return 0. Now I've got an executable code. We're ready to go. So What I'm going to start with is I would like to represent a room. So in order to represent a room, there's some things I need to know about that room. So if I've got, let's say this is the living room. It's got a length going across and a width. And then if I have a kitchen, it's got a length going across and a width. So every time I make a room, I've got the same kind of properties for everybody. So if I was to emulate that, I would say, okay, let's just say they're going to be integers. Integer living room length equals 12, and living room width equals 13. Just say integer kitchen length equals, I don't know, big. Let's have a bigger but less wide kitchen. There. So in this case, I've got this living room and this kitchen. They both have a length and a width. Well, then when I go to make another room, I've got to come up with two more variables. So what I can do is I can actually make my own data type and put some of these together. I can do that with what's called a struct keyword, or struct, S-T-R-U-C-T. So if I wanted to say that everybody who was a room had a length and a width, I could actually make my own structure using the keyword struct. As you can see, it turns blue. And I can give this structure a name. Let's say I call it a room. So I've got this name, I've got this, what we're going to call it, the identifier. And then I've got to say, well, what goes in it? So what's inside of every room that we have? Well, every room is going to have a length, and it's going to have a width. And the reason this guy has a semicolon is because this is just a declaration. We're telling the C language that, hey, I'm making a new data type. It's going to contain these items. And that way, when I try to use it later, you know what it is I'm talking about. So we haven't taken up any room in memory yet. We're just telling the compiler, here's what we're going to do. And then now that I've declared this structure, I can then use it by using this guy here as my data type, because I've just declared a new data type. So, just like I would int living room length, I can just say room. And I can say living room and kitchen. So just like that, I created a new data type of type room. My variable names is living room and kitchen. And then in each of those both have two things, a length and a width. And if I wanted to access those, I would use the access modifier, or the access operator. So I could take a living room, hit the dot, and that is the access operator. And now as you can see, I've got a length and a width. I've got two options there. So I can set the length to equal 12, and then I can do the width to equal 13. I can also do the kitchen, take the length of the kitchen to be 18, and the width of the kitchen to be 8. Now this might be an easy example. However, you can kind of see where we're going with making our own data types. Could I do the same thing this way? I could. But this allows us to do some code reuse and allows us to be a little more clear on what it is that we're talking about. Every time I use the dot operator or the member accessor, I say that this guy is a part of the guy on the left. So, to make things even more fun, I could also do a room pointer. Uh-oh, here we go. So, pointer to the kitchen. How's that? So now I've created a pointer to a room. It's called P Kitchen. And then if I wanted to assign that, I would say P Kitchen equals the address of kitchen. And that allows me to have access to what's inside of kitchen. Now, in order to use that, what do I need to do with the pointer? I need to dereference it. Because again, right now it just points to a spot in memory. If I want to actually go to it, I need to dereference it. So I would use P Kitchen, and that would dereference it. And then I could use that member operator and try to type in length. But when I hit the dot, I don't get a little drop-down box anymore. You think, well, that's kind of weird. Let me just type it in myself. Maybe this thing doesn't know what it's talking about. Well, you'd hope so, but it doesn't. It knows what it's talking about. And the issue is the asterisk is a lower operator than the dot. So this tries to take P Kitchen, grab the member length, and then dereference it. So, to make this work, we've got to use the handy old parentheses. Now if I hit the dot key, my options come up. Because we have it correct. We're dereferencing the object, and then we're accessing what's inside it. Some people say, well, that's messy. So what they did is they came up with what they call the arrow operator. So if you've got a pointer, you can use the arrow operator, which is a dash followed by a greater than sign, to get to the items that you're trying to change. So now we just changed the width of the kitchen to be 23. And let me go ahead and assign this one too, just so you can have it for clarity. So on line 20 here, we're using the member operator by dereferencing the pointer first. On line 21, I'm using the arrow operator. Because this is a pointer, I can use the arrow operator to get to the members. So this is an example of making our own data type. Of course, I can make my room have as much properties as I'd like. Let's say I just want to go ahead and bool has door. I'm going to do a int num windows. And just like that, by adding this to the structure, all of these data types that are type room now just got added those properties. So now the living room, kitchen, both have the value door, and they both have a number of windows. They're currently not set to anything, but just by changing it up here inside my structure, that gives it to everybody else. So this is our first introduction to code reuse and encapsulation. Questions there? Yes, sir?
Bool has door. Is that going to initialize to null, true, or false?
Well, it has initialized to anything. So right now it's whatever it points to in memory at the time.
So it's just a bunch of badness.
So yeah, it could be anything. We haven't talked about initializing yet. So now down here, if I wanted to take P Kitchen and then say that it does have a door, I can set it true. So P Kitchen now has a door. Again, because I made this one structure, we're using it everywhere. I add it here. Now everybody gets it. All right. Any questions there about a structure? Sounds easy, right? Yeah. The practical application that kind of stones everybody up. All right. Well, with that, we've hit our time limit. So I will take this, zip it up, put it up there as the in-class example. And then next week we're going to jump into object-oriented programming in classes, which will be loads of fun. So if you guys don't have any questions, that's all I have for you.